So this screen, which is on page 346, this is a description of doing transformations for exponential functions. There's a lot of information there. We're going to go back to the same thing we did in chapter 3, which was move left to right when doing our transformations, and we're going to do the same thing for exponential functions. So they've written this with y minus k. I'll just use the same letters. We'll move that k over to the other side, and then we will just work from left to right. So we'll do an example to start with. Graph y equals -5 times 3 to the 2x plus 4 minus 7. So the first thing that you have to do, the same thing we did in transformations, was recognize what kind of graph this is. And seeing the x in the exponent is telling us that's an exponential graph. So once we know that it's an exponential graph, we have to figure out what the parent graph is. The parent graph is going to be y equals something to the power x. And in this case, the base would be, yes, 3. So the first thing you're going to do when you have to graph exponential graphs with transformations is recognize that parent graph, y equals 3 to the x, and draw a quick sketch of it. So because it's a 3, it's increasing. You know that it goes through 0, 1, and 1, 3 with an asymptote at y equals 0. The other thing I like to do with exponential graphs is after I've determined what my parent graph is, I go back to my original equation, and with a different colored pen or something, I sort of box off that parent graph. I put a box around the 3 and a box around the x, because one thing that's different about an exponential graph is there's a number that's part of your parent graph. Okay, that 3 is part of your parent graph. It's not going to be one of the transformations that you have when you move left to right. When I move left to right, when I'm looking at my transformations, I'm going to have a -5. That's going to multiply my y values by -5. Then the 3 is part of my parent graph, so that doesn't affect the transformations at all. The next thing is the 2. That's going to multiply my x values by 1/2. The 4 is going to move it 4 to the left, and then it's going to move it 7 down. So I like to box that 3 and that x off to remind myself, not only do I not include that in my transformations, the other thing that you will be tempted to do is like, oh, there's -5 times 3. What's that equal to? -15, and you'll be so tempted to write -15. But order of operations say you have to do exponents before you multiply, and there's an exponent here. So unless you can put 3 to the 2x plus 4 and write that as a number, you can't multiply by that -5 in front. But it will be so tempting. And some of you are going to fall into that temptation and multiply that 3 by that -5. It's going to happen. I'm warning you, don't do that. So sometimes putting that box around that 3 and the box around the x to say that's part of my parent graph helps remind you I shouldn't multiply that 3 by that -5. So now going about our transformations, we can start with our key points. We'll also do our asymptote here. We'll leave our asymptote for the end. And we can do the same arrow thing that we did before. First, working with all of our stretches. So going from left to right, the -5 means y by -5, and the 2 means x by 1/2. And so we can do all of our stretches and compressions first. The nice thing about this question, I don't know if you noticed, but the horizontal compression was already factored out. Do you remember that special note that we had before? That you always, if you have a horizontal stretch, compression, or reflection with a horizontal translation, you always have to have it in factored form. And this one already is. And next, as we continue to left and right, from left to right, we got the 4, so that's going to be 4 to the left and 7 down. Four to the left will take us to -4, 7 down to -12, -3.5, and -22. And now we're going to look at our asymptote. When you have an asymptote on the x-axis, it's true if you have it on the y-axis too, but multiplying that y value, which is equal to 0, by anything won't affect that asymptote. The only thing that's going to affect a horizontal asymptote that starts on your x-axis is whether you move it up or down. In this case, we do move it down, so we can put a big arrow all the way over to here, and our asymptote will be at y equals -7. Once you have your asymptote and those 2 points, you're going to be able to graph it, yes. So start with your asymptote. Y equals -7. Plot your 2 points. So we have -4, -12. And -3.5, -22. I'm just going to estimate where that would be. And we have those 2 points. Now these 2 points are going to be connected, so we know this much. Which way is the graph going to curve? Well, because -3.5 is further to the right than -4, you would know that this graph was heading in this direction. Put arrowheads on the end of your graph, and there we have it. If we think about our original graph and moving from left to right, the first thing we hit is the -5. That -5 is going to stretch the y values and flip it over the x-axis. So that would start with a 1 transformation by doing that. Then the 1/2 would compress it, so it would be even steeper than it was before. Next, you'd hit your +4, which would move it 4. Whoa, that was fancy. Next, you'd hit your +4, which would move it 4 to the left. And finally, you would have your -7, which would move it 7 down. Does that seem to be the same shape that we got in the end? Yes. So sometimes when I'm done a transformation graph, I sort of re-go through each of the transformations and just imagine what that would do to the graph. Just so that I can see, is the general shape of my final graph match with what I have? And in this case, yes, it does.